In this video, we're going to talk about double integrals and integrating over a general region. In this example, we're given a function of two variables x and y. F of xy equals 2xy minus 4y cubed, and D is the region bounded by y equals x cubed and y equals square root x. And we're asked to find the double integral of the function f over this region. So if we were to integrate the function f over this region D, our double integral here would turn into this iterated integral with the x going from 0 to 1, the y going from x cubed to square root of x, and our integrand being the function f. So where do we get these bounds for the two integrals? Well, if we were to plot the two curves that make up the region D, the two curves being y equals square root x and y equals x cubed, our graph would look something similar to this. And the region that's bounded by these two curves is the region where the x varies from 0 to 1. So since our x is varying from 0 to 1, that's why our outer integral here related to dx has the bounds 0 to 1. Now also looking at this graph, we see that the y varies from y equals x cubed up to y equals square root of x. Because this is where our y varies, this is why our inner integral goes from x cubed to the square root of x. Now that we've set up the appropriate iterated integral, the rest is just doing simple integration. So if we integrate the inner integral, we get the integral from 0 to 1 of x y squared minus y to the fourth, where y is evaluated from x3 to square root x. Then we can use algebra to simplify all the way down to where we get the integral from 0 to 1 of negative x to the 7th plus x to the 12th dx. Once we have this is a simple calculus 1 integral. From here, we arrive at the final solution of negative 5 over 104. So we can conclude that our desired double integral is equal to the value of negative 5 over 104. So again, the toughest part about a problem like this is figuring out the bounds to turn the double integral into the iterated integral. Once this is done, it becomes a simple procedure, just as we've done before.